This is lesson 47, VHDL example 28. And you remember in the last lesson 46, we designed a 4-bit adder using logic equations. Now it would be nice if we could just use a plus sign to design an adder, and it turns out in VHDL you can do this. And let's see how it works. Here's the 4-bit adder we had, and we made a 4-bit adder out of 4 full adders. But here's what you do. To get the carry out C4, we'll just append zeros to the A. So here's the 4-bit A in, 4-bit B in. We'll add 2 zeros. Then the plus sign in VHDL, if we add these two 5-bit numbers, say call it temp for example, then we'd have a 0 carry in, and we get the normal sum out. The sum S3, S2, S1, S0 will just be this temp 4 down to 0. And the last carry here, if there was a carry, there isn't in this case, but if there was, that would be C4. So if we use the plus sign, we'll get this sum out, which if we add this additional 0 at the beginning, this leftmost sum would be the carry bit then. But how do we get the overflow bit? Because we don't have access to C3 at this point. Well, here's the trick to do that. Look at the truth table for a full adder. Once you do the sum, you'll know the sum. Of course, you know A and B. And it turns out that this input CI is just the exclusive OR of the sum out, exclusive ORed with A, exclusive ORed with B. You can see it from the truth table. Remember, if you exclusive OR 3 things together, this is like a 3-input exclusive OR gate. The output will be 1 if the number of input ones is odd. Well, here they're even, 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 so the output C is 0. Here 1 is odd, 1 is odd, 1 is odd, 3 is odd, so the output CI, you see, is just SI exclusive ORed with AI, exclusive ORed with BI. And the overflow bit was just, in our case, C3 exclusive ORed with C4, or in general CI, the next to last one, exclusive ORed with the CI plus 1, the output. So this would be like C3 or C4, where this would be C3 in terms of S3, A3, and B3. So that's how we can get the exclusive OR flag. So let's write a VHDL program. Now for the plus sign to be used, we've actually used it without talking about it too much in previous lessons, but we must include this IEEE unsigned. This will allow us to use the plus sign. We'll say more about this in the next lesson. So in our case here, A is 4-bit in, 3 down to 0. B is the 4-bit input, 3 down to 0. S is the 4-bit output, the sum, 3 down to 0. And then we have the carry flag and the overflow flag. So we define a variable temp, standard logic vector 4 down to 0. And then we define temp, and remember colon equal for variables, is a 0 prepended to A and a 0 prepended to B. And so the temp is just the sum of this, in this case, 2 5-bit numbers. The sum then is just temp 3 down to 0, the lower 4 bits. The carry flag is temp 4. And the overflow flag is temp 3, which is really the sum 3 exclusive ORed with A3, exclusive ORed with B3, exclusive ORed with temp 4, which is the carry flag out. So that was the logic equation that we had for the overflow flag. And we can check it by doing a simulation. This is the same simulation we had in the last lesson for the 4-bit adder using logic equations, where we added this 1 through F to B, or 11, and you'll see we get exactly the same answer. Here's the carry flag, and here's the same overflow flag that we had before.